name is Joseph Achtman. I'm the CEO of Gamaya. It's a smart farming startup based in Lausanne. It's a spin-off of EPFL. And basically what I would like to share with you is how Gamaya came to be and what our mission is, and we are on a mission here. So I titled it The Third Agricultural Revolution, and I'll try to explain what I mean by this. But I would like to start just a few words about myself. So I have mostly academic background. I did 15 years of applied research across several domains: environment, automation, sensing, and the one theme that was consistent throughout these themes is the edge between technology and environment. A few years ago, in 2012, I got involved in a project which really changed my life. It was a really significant point in my career. The idea of the project was to fly 7,500 kilometers from Lake Geneva to Lake Baikal in southern Siberia and to study the environment, study biodiversity, map biodiversity, and to study the impact of human activity on the environment. So we did large portion of this flying. Some portion of it we took the ultralights and trucks. So the ultralights is this little plane, it's like a trike with a wing. It's an incredible little flying machine. I'd like to thank the people, the sponsors who allowed us to do this incredible journey. It was research, it was adventure, it was expedition, it was everything mixed. And maybe I'll be able to show you just a few working moments from how it looked from the air. So we had 5 of these machines flying together in a formation. If the technology will allow me, it was just an incredible journey. We flew all across Europe and in Siberia. So I'll cut it a little bit short, but yeah, there's a whole documentary been done about this incredible project, which I will invite you to explore. So basically what we've done during this project, we developed an entirely new what is called remote sensing platform. It's what is called imaging spectroscopy technology that basically allows you to study the chemical properties of a surface from a distance. So we could actually study the properties of vegetation and land cover from the images that we collected from the air. And the first system that we built, it was a very expensive system. It was to a certain extent unique in its kind, and it weighed about 15 kilograms in 2013. Then in 2014 we scaled it down to 5 kilograms, and then finally in 2015 it was 250 grams. And this will allow us to basically dramatically change the methodology and deploy this type of system from any small drone that you could put a GoPro in. And this opened a whole range of different possibilities for us to do both research and commercial applications. And this was patented in 2015. So just to explain to you what this hyperspectral imaging does, it basically analyzes light across a very large number of separate spectral bands, and it allows you to really, so this is how the what is called delta of river Seringa looks like, which is a very big region in southern Siberia. So to human eye it looks completely green. To this camera it just looks an explosion of colors that allow us to analyze the different types of vegetation, map biodiversity, and do the whole bunch of different things from this imaging information. It basically scales the human color space, which is 3-dimensional color space, to, in this case, 40-dimensional color space. And since then, in fact, this is just in 2015, we've been involved in over a dozen different projects in all these regions around the world where we conducted research and more lately actually commercial applications. But what we found is that the less bright side of things is that the extent of human impact on the environment is just mind-blowing. Anything from massive bleaching of coral reefs in Indian Ocean to invasions of toxic algae in the lakes in the Far East in Russia, to catastrophic forest fires in the Russian taiga. All these things that I experienced firsthand just made me thinking about where we're heading and what we can do about it. And what we converged on once we decided to actually commercialize the technology is that we need to focus on agriculture. So I'll try to explain to you what the problem in agriculture is. This is a very conventional picture. This is really the consensus. The consensus says that we need to produce 70% more food in the next 30 years to feed 10 billion population, where human population is projected to saturate. However, we don't necessarily agree with this conventional understanding of things, and I'll try to return to this point later on. Just keep in mind this picture, I'll come back to it later. So what is happening is indeed, as we heard a very astute talk this morning, and this is what is happening to human population, it's an exponential growth. However, it is not completely clear how this exponential growth can be sustained. In fact, we know a lot of natural systems that experience exponential growth, and what we know about them, and here I have to say something quite like dark side of what was said this morning, is that what we know about exponentially growing exponential system is that they tend to catastrophically collapse rather than reach singularity. And we have to be extremely careful here. We have to really think very hard, how do we realize this wonderful rosy future of reaching singularity and sustaining immortality without basically destroying our planet and the environment, which is very much what is happening today. So these exponential systems are indeed very complex. So in order to break this down a little bit more, I'll convert this vertical scale into logarithmics, which is what you do when you study exponential growing systems. And what you see here is absolutely incredible. You see that in the, so you have this basically only three phases, major phases of trends in how the human population expanded. So you basically have essentially, there is a lot of fluctuations here in the era of empires, as empires rised and collapsed. But other than this, you have just only three phases. So what this means is that there were only two technological events that actually had a significant impact on how humankind has developed. First of them, 7,000 years ago, we transitioned from a nomadic hunter-gatherer society to agricultural society. So this was what is called agricultural revolution. The second event was actually just about 300, 400 years ago, and this was what is called industrial revolution, where we basically started to use for agriculture, instead of using muscle power of both humans and animals, we started to rely on hydrocarbons. So basically using first coal, then oil to produce our fuel, but then produce our food, but also producing everything else around us. And this obviously changed the nature of humankind dramatically. So basically what you are seeing here is the transition of the humankind from one ecological niche to a different ecological niche. So there were only three these ecological niches that essentially humankind has ever occupied. And the difference between these ecological niches was defined by nothing else but the way that we produce food, where we take our energy from, and how we feed ourselves. So another very telling story is the story of energy. So this is actually the story, the illustration that underpins the Moore's law, is how we double these transistors every 2 years. We also doubling our consumption of energy. And in fact, this is a very steady, exponential, purely exponential process, we basically use about 3% more energy every year. But you actually, when you extend this, extrapolate this curve further, and this curve, what is amazing is that this curve has been absolutely steady for the last 400 years. So if you try to extrapolate it further, you realize that within a couple hundred years, we will raise the temperature on Earth to such extent that all our oceans will boil. So what you learn from this is that the change in the ecological niche, the third transition of the ecological niche of humankind is imminent. It will happen within our lifetime. So this is a little bit, there are several scenarios of how it can happen. Singularity is one of them. There are some more darker scenario, and we need to make sure that singularity happens and not catastrophic collapse. But one way or another, it will happen within our lifetime. This is a tremendous. So it's a thing. So it's a very exciting indeed time to live in. And this is a more detailed breakdown of ecological niche that we right now occupy as humans. We take basically all of our energy, most of it, from hydrocarbons. So just burning basically coal and oil, and we convert it into heat, carbon dioxide, and other forms of waste. In addition to oil, we use a few other resources such as soil and water. And today we are using 70% of all arable land. So 70% of all land on Earth that can be farmed is already farmed today. This is an incredible number, considering that we need to grow the food production by 70%. So the question is, now I drew this a little bit dark picture, which is, I think, contrasting quite a bit from what we've heard earlier today. So what do we do about it? What we do about it is we go smart. We basically become smart about how we grow our food. So to illustrate this situation, I would like to focus on a particular industry which we studied very much in depth over the last few months, is the sugarcane industry in Brazil. It's a biofuels. It's a huge industry. It has a revenue of about $70 billion per year. So they have about 15% of losses due to various kinds of inefficiencies, weeds, planting gaps, disease, etc. The operational expenses are 60%. So 60% of this revenue is going into fuel, which is actually, surprisingly, it's not biofuel, but it's a diesel from fossil fuel-based diesel. It's chemicals, and it's machinery. And they have production expenses, of course. In the end, they end up with an average profit margin of 3%, which for an industry of this size is a little bit strange. Finally, the emissions, so greenhouse gases emissions, are about 20 megatons per year. And this is another very strange number, because sugarcane is in fact the most effective plant known to man to convert carbon dioxide, capture carbon dioxide, and store it. So sugar cane is very effective in capturing sunlight, converting it to sugars, and creating very biomass from carbon dioxide very, very rapidly. So how did we manage to create a sugarcane growing, so creating carbon dioxide by growing sugarcane is quite amazing. So can this picture be changed? This is the big question. And it turns out that it can be changed quite relatively easily. So our approach, I'll try to show you, demonstrate to you our approach to this. So we use these little drones. Sometimes they are small drones, some they are bigger drones, sometimes they are proper manned airplanes. It depends on the scale of the survey. But basically what we do, we fly over fields, and then with this hyperspectral camera, and then we create this layers of information that allow us to create situational awareness for farmers. So to make sure to basically address the bottlenecks in the methodology of large industrial farms that allows them to very significantly increase efficiency. So some examples of what we do specifically for sugarcane is detecting sites with potential soil erosion, early detection and classification of weeds, detection of planting errors, estimating biomass and planning harvest, and a few other things. So what this leads to is that we are able to increase their revenue, half their losses, significantly reduce their operational expenses because they use less fossil fuels, and finally we can triple and sometimes we can increase the profit margin by a factor of 15. So we are right now running pilots with large industrial producers of sugarcane in Brazil. We are trying to validate these figures, but this is what came out from our very detailed analysis for what we do for these businesses. So the thing is that in the end what we do is we increase the efficiency of sugarcane production by about 15 to 20%. And what this does is that it makes sugarcane-derived ethanol a little bit more economically viable than fossil fuel-derived diesel. And it creates an incentive for farmers to actually operate their machinery on biofuel-based ethanol instead of imported diesel. And so this closes the loop, and hopefully this is a little bit of extrapolation, but there's no magic or science fiction involved. We can actually make these businesses completely carbon neutral. We can change them from being very much dependent on oil and being very significant producers of greenhouse gases into businesses that are completely carbon neutral and later on even carbon negative. So generally speaking, the fact that agriculture actually with the land cover change accounts for about 25% of all the carbon dioxide emissions of human society. And this is, as I mentioned, in the case of sugarcane, this is a very unnatural situation because plants eat carbon dioxide for breakfast. This is what they eat. Every tree that you see around us is made of carbon dioxide. And so the situation where we create carbon dioxide by growing plants is completely unnatural. It doesn't have to be this way. So our mission in Gamaya is to change that. We actually think that it's completely possible to make agriculture, which today accounts for 25% of all greenhouse emission gases, to be completely carbon neutral. And this is obviously a very big challenge, but we think that it's perfectly possible to do. So coming back to this particular picture, I actually believe that it's completely wrong. This 70% increase in food production, which is formulated by, it's a very capitalistic approach where you need to grow. But the reality is that there is more money spent in the United States alone on fighting obesity, which is overeating, than required to feed all the hungry people on Earth. And so the idea that you need to increase productivity and create more and more food is, in my opinion, is wrong. What we need instead do, we need to make agriculture 100% sustainable and carbon neutral, and later on to actually make it carbon negative to outweigh other industries. And this will close the loop and make humankind existence sustainable, and will allow us to actually reach singularity, which obviously sounds like a really great idea. So we, along the way, we've been supported by all these wonderful awards and people. We are working with some of the prominent business organizations in Switzerland to realize our mission. We've been recognized by Forbes as one of the unicorns in AgTech in Europe. So this gives us the feeling that we are doing something right, that we are on the right track, and we are very much we actually think that we can realize our big mission to feed the growing human population and make humankind sustainable to allow us to reach singularity. And I thank you very much. We have an amazing team. This is in the field, in the soybean fields in Brazil a couple of months ago. So I thank you for your attention. Thank you very much.